6 AB free response number 5. Okay, so we are given a differential equation. dy dx equals 1 plus y all over an x for x values that are not equal to 0. So part A, on the axes provided, sketch a slope field of the given differential equation at the 8 points provided, and notice that I put the points in red. They're not in red on the AP, but you only want to do the points they asked for. First thing to notice here, this is a separable differential equation. You can move the the x's and y's to different sides. That means that this is probably a two-part problem. Part 1, slope field. Part 2, worth all the big points, is going to be separating the variables and solving. So the big points here are going to be in part B, is what I anticipate. So let's go ahead and do our slope field. So how much work you need for a slope field is going to depend a lot on you as a human. And there's nothing wrong with that. It's totally fine. If you want to play it extra safe, you can make a little table of values. So I know what these 8 points are, right? So if I want, I can make my x and y points, and then I can find the slope at those points knowing that the slope is 1 plus y over x. If you want to do this in your head, that's absolutely fine. Nobody cares. Nobody's giving you a point for this work. You just have to get it right. But if you make a simple calculation error and you lose these points, you're going to be kicking yourself. So I'm going to go ahead and put the coordinates. So this is -2, 0, right? And then I'm just going to start at the bottom and work my way up. I always start all the way left and then work bottom up. I don't know why. So -1, -1, right? -1, -1, -1, 0, -1, 1. Nothing at x equals 0, right? And then 1, -1, 1, 0, 1, 2, and then my very last point should be at 2, 0. So again, how much work you need to show is going to depend a lot on you as a human, and that's fine. So when I plug a -2 in and a 0, I get 1 over -2, right, which is -1/2. When I plug in -1, -1, I get a 0 over a -1, which is a 0. When I plug in -1 and 0, I'm going to get a 1 on top of a -1, which is -1. When I plug in a -1, 1, I'm going to get a 2 on top of a -1, which is a -2. When I plug in 1, -1, I'm going to get 0 on top of 1, which is 0. When I plug in 1, 0, I'm going to get, oh, sorry, and that's a 1, 1 there. I don't know what's wrong with my brain. When I plug in 1, 0, I'm going to get a 1 over 1, which is a 1. When I plug in 1, 1, I'm going to get 2 over 1, which is a 2. And when I plug in 2, 0, I'm going to get a 1 over 2, which is just a half. So when the AP gives you a grade for this, there's a good chance that they're going to give you a special bit of notice for the 2, 0 slopes. So the 2 flat slopes are the ones that I always put on first. So at -1, -1, I should have a flat slope. And at 1, -1, I should also have a flat slope. Okay. When I put all of the other slopes in, so all of the other ones, so I do those first, and then I worry about all the other ones. So this is always my rise over my run, right? So when I'm here, I should rise -1 and run 2. So I'm going to point to this point right here, which is like there, right? When I'm at -1, 0, I should have a slope of -1, which means down 1, right 1. So I'm pointing to that same point. That should be slightly steeper than my half slope, my -1/2 slope. And then here I have a slope of -2, which is down 2, right 1. Oh, look, it's pointing to the same point, and again, that's slightly steeper. Over here at 1, 0, I should have a slope of 1, which is up 1, right 1, which is actually pointing to that same point. I'm just really bad at graphing. And I should have a slope of 2 right here, which is up 2, right 1, or down 2, left 1. But notice it's actually still pointing at the same point. And then when I get here, I have a slope of 1/2, which actually points at the same point. So actually all of them point to that same point. So that's my slope field. So this is worth 2 points, and they're pretty much usually going to give you 1 point for the weird slopes and 1 point for all the other slopes. In this case, they actually didn't. They gave you 2 points, and they said that the points need to have the relative steepness being correct. So for instance, my -2 slope should be steeper than my -1 slope, and they obviously also have to have the signs correct. So these have to be negative slopes, and these were all positive slopes. They're not going to get you if your slope of 2 looks like it's a slope of 2.1. That's not what they're checking for. They're checking for that it's relatively correct. Again, nobody's grading you just on sketching stuff. So part B, that was my part A. Part B is going to have me solve, and it's going to be worth all the points. In this particular problem, it's worth, it's worth an awful lot of points. So, I guess it's worth 7, because that first part was only worth 2. All right, so first thing I have to do is separate the variables, which means that the dx goes this way, and the 1 plus y goes this way. So I get dy over 1 plus y equals a dx on top of an x, right? So that's the first point. If you don't separate the variables, there is a note for the AP that says 0, no matter what. You could do anything after this, and if you didn't separate the variables, you'd get nothing. You could have, like, figured out the cure for cancer, and no one would care. I mean, they would care. That'd be awesome and everything. But, like, it would not affect your score. You have to separate the variables, right? So 1 point for separation of variables, right? Next point, you're going to have to find the antiderivatives. Now, whether you actually show this step or not is up to you, right? Both of these are fairly simple antiderivatives. They're both natural logs. Although this is technically u sub, since your du would just still be a dy, it wouldn't matter. So you're going to get this as the natural log of the absolute value of 1 plus y equals the natural log of the absolute value of x plus some constant of integration, right? Cool. So now they specifically said in part B, right? So at the start of part B, they said that they wanted the answer to be y equals some function of x, right? They also gave us the information that f of -1 is a 1. But what this means, this is code for solve for y. Now, you could try and find your c now, and that's totally fine. My preference is not to find c now. My preference is to solve for y and essentially use the fact that c is an arbitrary constant to make my life slightly easier. So I'm going to exponentiate both sides, right? So when I exponentiate both sides, that's intriguing. So when I exponentiate both sides, I'm going to get, when I exponentiate both sides, I'm going to do this. The AP did something slightly different than I would have done, but that's fine. Okay, so this is an e to the natural log of the absolute value of x times an e to the c, right? Because that's what happens when you add exponents. Now, I'm going to cheat and call this a new thing. I'm going to call it c sub 1. The way the AP got around this is they didn't use c for this first one. They called this k, and then they called this one c. That's fine. I would just point out that if you're going to rename this constant, if you take e to the c and call it something else, you need to call it a different letter. So, cool. So now what I have, now the other issue is that these guys technically cancel, right? These guys cancel. And when they cancel, there are two ways to do this logic, right? There are two ways to do this value. So you can either, right, write this as just an x, right? Like, technically what the AP wants you to do is they want you to call this an absolute value of x. The AP wants you to say, hey, this is this times c sub 1. And they used just a c, but you get the idea. This is what the AP wanted you to do, right? And then the AP wanted you to plug in this value. So I'm going to make an argument that there's another way to do this. And I'm going to show you both. So I'm trying to explain why there are two different solution methods here. The other way to do it is just call it x, right? Whichever way you do it, you're going to get a different c, right? So, like, the two options here, you're going to get a slightly different c value. Both answers would be correct, okay? So, bear with me for a sec. So, if you plug in here, right, what I want you to notice is that this x is negative. And the reason the less than 0 matters is because an absolute value of x changes value at 0, okay? So this x happens to be less than 0 in this instant. So if you were to plug in this value, so let's do these two options. If you were to plug this in, you'd get 1 plus the y value equals c sub 1 times the absolute value of -1. So you'd get a 2 as your c sub 1. And your answer would be 1 plus y equals 2 times the absolute value of x. So you'd solve and get y equals 2 times the absolute value of x plus 1. But the other way that you could deal with this, right, is that you could have not used the absolute value, this is the go-to instinct that I would have used, and you could say 1 plus 1 equals c sub 1 times a -1, and you'd get a -2 as your c sub 1. So your answer, right, the other answer, would have been y, it'd be the same answer, except your c sub 1 would be negative, so you'd get, oh, sorry, I made that a plus, and I didn't mean to make that a plus. Subtracted it over and apparently can't do simple math. So y equals -2x minus 1. Now that's also fine, but there's a caveat to both of these answers. Either of these answers is fine. Here's the caveat. Because they went out of their way at the beginning to say that x values can't be 0, like there are no solutions. Like, this is essentially a vertical asymptote for the f of x graph, right? Like, you can't cross this. So the reason that's important is that whichever of these solutions you wrote, it doesn't matter. Like, you could write this or this. The AP put either. You need to clarify that these solutions are only good for x values less than 0. Now that's not something that usually comes up. It's definitely a trick at the end of the question. But the reason they went out of their way to point out to you that this graph doesn't exist at 0 is to point out that essentially what you're looking at is two branches of a graph. There's a branch on this side and there's a branch on this side. The solution they asked you to find in part B is the solution on this side, so you need to quantify that this solution only works for things on this side, because on this side it's going to be a totally different graph. So again, that's a little bit of a tricky thing. Typically this whole section of work is worth 6 points, sometimes 5. The reason that this section was worth 7 is because they gave you an extra point for spotting the trick with the domain. I do think that was a little bit tricky. I think it's one of those things that if you're not paying attention, you could easily miss that point and get the rest of the question right. Again, either of these is fine. So if you were looking at this thinking, Hogan, how'd you get rid of the stupid absolute value? What are you thinking? Then maybe this is not what you would pick. If you had picked this and kept the absolute value, totally fine. Either answer is completely acceptable as long as you include the domain restriction because you're on this half.